So we're working with exponential and logarithmic functions, and so just to kind of introduce these and put them side by side, this is an example of a general exponential function that looks like a times b to the x, and notice the x is the variable up in the exponent, and then the second kind of function that we're going to look at undoes that first exponential function, and that is having a logarithmic function, which is in general going to look like a log. And then there's going to be a certain base, and I'm going to use the letter b here of x and to denote that this base right here, b, is the same as that base right there. So whatever the base of the exponential function is exactly the same as the base of the logarithmic function. Let's start with looking at kind of a simple example of an exponential function, and so we'll look at f of x equals 2 to the x. And notice that there's no a value out front, or not one written at least. That's because it's like a 1, so it's 1 times 2 to the x. And if you think about kind of the x and the input and output values of this function, you can make yourself a little t table, a little xy table, and if you plug in values of x, plug in 0, 1, 2, 3, so on and so forth. You can plug in any values you want there. When you plug in 0 in for x, you're going to get 1. When you plug in 1, you're going to get 2, you're going to get 4, when you plug in 2, and when you plug in 3, you're going to get 8. And so if you notice, every time in the table, as x goes up by 1, the output values are multiplying by 2. And that's because the base over here is 2. And so this base is talking about kind of how quickly your function is going to grow. Sometimes we call that a growth factor, or if our values are decreasing, we call it a decay factor. And then another important part of the exponential function is that your first value that's out front, the a value, is going to be your y-intercept value. And so notice in this case that's 1, where when you plug in 0 for x, you get 1 as your output. And so that would be your y-intercept. And that's always true up here with the a times b to the x. You always have your base as the b value, and you always have the y-intercept as your a value, just in general. So whatever values are there, you can tell kind of how your function is going to behave based on your y-intercept value a and your base value